Cool. We're going to do the square inside of a circle inscribed in a circle. So we just start with a circle for this construction, for the square inside the circle. And we have basically one of two choices going forward. We can either make another circle on the outside of the circle we just made, or I'm going to put my, it's hard to see on there, that's the center of the circle, or I can draw a line that goes through the center of the circle and creates two new points for me on the circumference of this circle. So if we're going to call this maybe circle A, all right, these guys might be points B and C. Great. All right, so now I'm going to stretch my compass from B to C, so the whole distance, the diameter of the circle A, and I'm going to do an arc above A and below A. So again, this perpendicular bisector piece, I don't need to do the whole circle, just where I see, if I know that the line I'm going to draw goes through A, let me make sure I've got arc marks above and below A so I can get that to go through it. And you can go ahead and draw this very lightly going through there. And let's call this point D and E. And now we have all of the points we need in order to make that square. All right, hopefully you can see how if I just rotate this, there are the corners of my square. So let me go ahead and connect BE, EC, CD, and lastly, BD. So, you know, there's multiple ways that we can kind of look at this and say, oh, I can figure out that these guys are congruent, because again, squares all have to have congruent sides. All right, so I can use this as my measuring tool, and I can clearly see that all of these guys are the same length. That's great. But another thing pops out here, and the fact that these guys are all, it's just four triangles, right triangles specifically, that are formed by this perpendicular bisector. This length has got to be the same as that length, because they're both radii in circle A. And it's also got to be the same as that one and that one, because those two are also radii in circle A. And anytime you've got a right triangle like this and two sides are the same, it has to be that this guy is going to be also the same as this guy. So the hypotenuse in my right triangle, so I'll call this guy hypotenuse. And that's only true in right triangles, all right? But the hypotenuse, these guys all have to be congruent, because the side lengths, the legs, if you will, all right, we call those guys legs of a right triangle, the sides, they're all the same as each other. And so that triangle has to be congruent with that triangle, has to be congruent with that triangle, has to be congruent with that triangle. And if that's true, all the hypotenuses are also congruent.